Hello, this is the second video to number systems and we will see some examples. So we have negative square root of 31 and we need to find what number systems does this number pertain to. So given that we have a negative, we know that it can only be either an integer or one of the sets lower to it. If you're not sure what those sets are, feel free to go back to the previous video. However, we know that square root of 31, we know that 31 is not a perfect square. So because of that, the square root will not be an integer. It will not be a rational because a rational requires repeating decimals, because every time something can be represented by an integer divided by another integer, we find a pattern and some repetition in the decimals. However, the square root of a number that is not a perfect square will never have this property. So the negative square root of 31 can only be an irrational. So something to keep in mind is that every time you have the square root of a number that is not a perfect square, it will be an irrational number. Now we have square root of 81. In this case, 81 is a perfect square because 9 squared equals 81. So square root of 81 is actually equal to 9, which we know is an integer, because as you might recall, integers go from negative infinity to infinity, but only when they without decimals. And since it is an integer, we also know that it is a rational number because all integers are rational numbers. However, we can also know that 9 is a whole number because, as you might recall, whole numbers go from 1 to infinity also without decimals. And if it is a whole number, you might recall that the system just under whole numbers was the natural system. So 9 is actually found in almost every system. It's an integer, a rational, a whole, and a natural number. Very well. Now we have negative square root of 48 over 3. 48 over 3 is actually equal to 16, so this is equal to this should not be an equal sign. This is equal to negative square root of 16. 16 is a perfect square. However, here the negative gives us some limitations. So it's negative 4, and we know that whole numbers and natural numbers do not contain negative numbers. So this is an integer. But we know that all integers are also rational numbers. Very well. Now, graphing. So these are some things that you will see when you have a number line. So when you have a number line like this, you will find sometimes just a circle around a number, a circle filled, maybe a circle and then something to the right, or maybe something to the left, and we will find what all of those mean. So this means that the set doesn't contain that number. This means that it contains the number. So it contains the number. In other words, it's equal to. This is thought as just the greater than sign. This is the greater than or equal sign because it doesn't contain, the set does not contain this number, so it cannot be equal. However, it contains all the numbers to its right, and the numbers to the right are larger. So 1 is larger than 0, 2 is larger than 1. So if we were to have this right here, this would mean that maybe x, or whatever this black portion represents, x is greater than 1. However, if the circle is filled, now it means that it can be equal to 1, so x is greater than or equal to 1. Now same thing with this one, just it's less than or equal, and this is less than. We will see some examples in a little while. I would like to highlight the fact that a kind of empty circle means that it is not equal to. However, since you cannot have an open circle just everywhere, when you have x is greater than or equal to 1, do not think that since x cannot be 0, -1, -2, or any of those, that you must put the empty circles. No, that's not true. That's not needed. Just not having anything, leaving it blank, just shows that x cannot be any of those values.